Welcome to Godwills Talent Hub, where talent meets opportunity.
Hey everyone, welcome back to Godwills Talent Hub. This is Satish, and today we are going to unlock one of the most powerful concepts in mathematics, prime factorization. If you have ever wondered how to break down any number into its smallest building blocks, or how to find HCF and LCM like a professional, then this video is for you. But before we dive in, if you are new here, hit that subscribe button and ring the bell so you never miss our math tutorials. And if you find this helpful, smash that like button. It really helps us out. Alright, let's get started. So, what exactly is prime factorization? Simply put, it's the process of breaking down a composite number into a product of prime numbers. Think of it like taking apart a Lego structure to find all the basic building blocks. Here are 4 key things you need to remember. The first one, every composite number can be expressed as a unique product of primes. That's actually called the fundamental theorem of arithmetic, which is mainly used for 10th class students. So make use of this. This would be pretty helpful for you while solving the real numbers chapter. Prime numbers themselves cannot be factorized further because they only have 2 factors, 1 and themselves. 3. We use prime factorization for finding HCF, LCM, and even simplifying square roots. And the 4th one, this concept is the foundation of number theory and is even used in modern cryptography and also your online banking security. Pretty cool, right? Now, before we can factorize numbers, we need to know our prime numbers. Let's do a quick review. A prime number is any number greater than 1 that has exactly 2 factors, 1 and itself. No more, no less. Here are all the prime numbers from 1 to 100. Take a screenshot of it if you want. This is super useful to have handy. Notice we have got 2, 3, 5, 7, 11, 13 and so on. And here is the fact that catches a lot of students. 2 is the only even prime number. Think about it. Every other even number can be divided by 2. So they can't be prime. Mind blown? Perfect. Now let's learn our first method, the factor tree method. This is super visual and really easy to understand. Here is how it works. Write your number at the top, step 2. Find any 2 factors that multiply to give you that number. Step 3. Keep breaking down composite factors. Step 4. Stop when you reach prime numbers. Step 5. Circle all your prime factors. Let's look at 36. I can break it down into 6 times 6. Then each 6 can be broken into 2 times 3. And look, 2 and 3 are both prime. So we stop. So 36 equals 2 times 2 times 3 times 3. Or in index notation, that's 2 power 2 multiplied by 3 power 2. The beauty of the factor tree is that it doesn't matter which factors you choose first. You will always end up with the same prime factors. Try it yourself. Now let's look at method 2, the division method. This one is more systematic and is actually my preferred method when dealing with larger numbers. Here is the process. Start with the smallest prime number, which is 2. Divide if possible. Continue with the quotient. And if you can't divide anymore, move to the next prime. Stop when your quotient becomes 1. Let's factorize 60. 60 divided by 2 is 30. Then 30 divided by 2 is 15. and 15 can't be divided by 2. So we move to the next prime number, that is 3. So 15 divided by 3 is 5, and 5 divided by 5 is 1, and we are done. So 60 is equals to 2 times 2 times 3 times 5, which is written as 2 square, which is 2 power 2 into 3 into 5. This method is super efficient and leaves no room for error. That's why it's used in competitive exams. Let's practice with a complete example. Let's factorize 72. So using the division method, 72 divided by 2 is 36. Then 36 divided by 2 is 18. 18 further divided by 2 gives 9. As 9 cannot be divisible by 2, so we stop 2 and then we jump into the next prime number, that is 3. So 9 divided by 3 is 3. Then 3 divided by 3 is 1. Now let's analyze our prime factors. The number 2 appears 3 times and the number 3 appears 2 times. So our final answer is 72 is equals to 2 power 3 multiplied by 3 power 2. See how clean that looks? This is the power of index notation. It makes everything so much more compact and easier to work with. Now, here is where prime factorization becomes really powerful, finding the HCF or the highest common factor. So let's find the HCF of 48 and 60. Factorize both the numbers. For 48, you will get it as 2 power 4 multiplied by 3. And for 60, you get it as 2 square multiplied by 3 and 5. Identify the common prime factors. We can see that both numbers have 2 and 3 in common. So take the lowest powers of them. For 2, it appears 4 times in 48, but only 2 times in 60. So we take 2 power 2, which is the least power of the common factor of 2. And for 3, it appears once in both, so we take 3 power 1. Multiply them together, and that becomes your HCF. So HCF is equals to 2 square into 3. 2 square is 4 and 3 multiplied with 4 gives you 12. And there you have it, the HCF of 48 and 60 is 12. So the key rule here is common factors, lowest powers. Remember this. This is the best way to remember and find out the HCF of any 2 or 3 even numbers. Now, let's find the LCM or the lowest common multiple using prime factorization. We'll find the LCM of 24 and 36. Factorize both the numbers the similar way. So 24 is 2 power 3 multiplied by 3 and 36 is 2 square multiplied by 3 square. Identify all prime factors present in either number. We have 2 and 3. Take the highest powers. For 2, it appears 3 times in 24 and 2 times in 36. So we take 2 power 3. And for 3, it appears once in 24 but twice in 36. So we take 3 power 2. Multiply all factors together. LCM is 2 power 3 into 3 power 2, which is 8 times 9, 72. So the LCM of 24 and 36 is 72. The rule for LCM is opposite to HCF. All the factors, highest powers. Once again, just to remember, for HCF, we take out the common factors and the least powers. And for LCM, we do exactly the same thing of factorization. Then we will write all the factors with the highest powers. Properties and rules. Let's talk about some important properties and rules you must remember. Every composite number has a unique prime factorization. This is guaranteed by the fundamental theorem of arithmetic. Prime numbers cannot be factorized. They are already in their simplest form. The number 1 is special. It's neither prime nor composite and has no prime factorization. For HCF, remember, common factors with lowest powers, and for LCM, all factors with highest powers. And prime factorization helps in simplifying the square roots and fractions too. And here is a bonus formula. HCF multiplied by LCM is the product of the two numbers. So for example, you have two numbers and you have found the LCM and the HCF. So the product of their LCM and HCF is equals to the product of those two numbers. You can use this to check your answers or to find one if you know the other. So why should you care about prime factorization? Let me show you why this is so important. First, the key takeaways. It's all about breaking numbers into their prime building blocks. You can use either the factor tree or the division method. Every number has a unique prime factorization, and we write it in index notation to keep it clean. But here is where it gets exciting. Real world applications. Finding HCF and LCM for solving word problems, simplifying fractions to their lowest terms, calculating square roots and cube roots, computer encryption, like your credit card info is protected using prime factorization, and digital security systems like RSA encryption. That's right. Every time you make an online payment, you're relying on the properties of prime numbers. Pretty amazing, right? And that's it for today's video on prime factorization. We covered what prime factorization is, learned two powerful methods, the factor tree and the division method, and we even learned how to use it to find HCF and LCM. Now it's your turn. I want you to practice by factorizing these three numbers. Leave your answers in the comment section. Number 1, 84, 2, that is 100, and number 3, 144. I'll be checking the comments and giving shout outs to correct answers. If you found this video helpful, please hit that like button and subscribe to Godwills Talent Hub for more awesome math tutorials. We upload new videos every week, and got questions? Drop them in the comments below. I read every single one. Remember, mathematics is not about memorizing formulas. It's about understanding the concepts. Master prime factorization and you will unlock so many advanced topics which you will experience in the future. Until next time, keep learning, keep growing, and I'll see you in the next video. This is Satish from Godwills Talent Hub, signing off.